before. HIV, the human immunodeficiency virus, causes AIDS, the acquired immune deficiency syndrome. There's kind of like, it goes from one phase where you're healthy, and then there's usually something that will trigger the person to transition into the AIDS phase of the disease. A lot of times it's pneumonia is a trigger, that the immune system gets so compromised by something else going on that then it really like overloads. So, you know, as I like to say, the immune system, when HIV is in the body, there's a lot of medications that can keep it very low and even undetectable at this point in the body. But if your immune system, so your immune system's doing a good job of, and along with the aid of the medications, it's keeping this either very, very low in the body or undetectable, that you could, let's say you get pneumonia or COVID, and it could make that virus overtake the immune system then. Specifically, it attacks the T helper cells, which seems like, well, that shouldn't be a big deal, right? But because the cytotoxic T cells are the ones that are doing the job of, you know, keeping the immune system overpowering the virus or whatever the invader is, and in this case, HIV. But the T helper cells are there to give a boost to the cytotoxic T cells. And so if they're not doing their job, the cytotoxic T cells essentially get like worn out and exhausted. This is a picture of the HIV virus entering the cells. One of the things about the HIV virus is that it's a very complex virus. If you remember back when we talked about viruses, that virus particles, they only need to be qualified as a virus particle is some kind of genetic material and then a protein coat. The HIV virus has a number of coats on it, and the outer coating, along with the surface markers, there's kind of two things, is that the outer coating of the HIV virus is very similar to the coating on our cells. So that makes it easy to merge, and then in addition, the surface markers also allow it to attach onto our cells easily. So here what you're seeing is basically like our cell's plasma membrane and the outer coating of the virus, it's merging just easily with our cell. And then, and one of the ways that it attaches on is from, see these little like kind of fuzzies on here? Those surface markers allow it to grab onto our cell surface, and then it's going to dump its genetic material into our cell, and then our cells are manipulated into processing more of those virus particles in the body. So I have a question. Look at me, I've got it in there. You would expect someone with AIDS to have a fever, or sorry, would you expect someone with AIDS to have a fever in response to an infection? So let's say yes, because the non-specific defenses should be relatively normal. Yes, because the specific immune response should be relatively normal. No, because the non-specific defenses should be compromised. And no, because the specific immune responses should be compromised. So which part of the 3 levels of the immune system cause fever? Is it the specific immune response? No. So you haven't even gotten there, which means that anything before the specific immune response, the adaptive immune response, those are going to be working fine, which means that fever, which is part of the non-specific internal barriers, will be okay. So I know, Emma, you had said yes, right? Yes, because the non-specific defenses should be relatively normal. So one of the things that we see, even though we know a lot about HIV and AIDS, is still, I mean, this figure is a little bit old, there's still millions of people that contract HIV every year. A big portion of that is just education. Is that the lack of education on the virus in some countries is lower, plus the resources of just protecting oneself during sex are not available or as readily available. So a condom would greatly lower the contraction or spreading of HIV. Remember also that it is passed from IV drug users, so people who are focused on getting a drug that they inject and they're not thinking about spending money on clean needles, is that they want the drug because of the addiction so badly that they are like, I'm gonna spend all my money on the drug and not get new needles, so they may share needles. And it is a blood-to-blood contraction virus. So as I mentioned before, we saw this. Here's what, the illustration of the HIV virus. Extremely sophisticated. That it has the genetic material, it's got a coding, another coding, as well as these surface markers. So there's a lot of different variants of this virus as well. There's a lot of research that's been going on for the advancement in the antiviral drugs, and that's one of the reasons why if you have the ability to get those drugs, it can stay, the medications, it can stay very low. The antivirals can make the virus very low, even undetectable in the immune system. And so they're seeing kind of like a cure in that way, but you still have to keep taking the antiviral medications. The other thing is that why, as I mentioned before, lack of education, but it's also lack of resources like condoms as well as these antiviral drugs around the world, that in some countries they just don't have the ability to access those drugs. So there's a lot of people who are trying to make those more available to countries that are poorer, where they can help get those antivirals out there as well. So there's a lot going on. There's also tons of research in terms of cures. They have, like I said, the medications can make it so low in the body that it essentially is undetectable. So it's another, I like to always mention to you all, there's another field of research where you can go, oh, maybe that's something I want to go into. Okay, so that's